Hey, what's up, insiders? This is Alex with another edition of Stone Industry Insider. And today, we're going to talk about how amperage works on a WF Meyers Quarry saw or any piece of equipment that is amp following and has a PID. No clue what I just said? Stay tuned. So let's start with the basics. An ampere, or an amp, is a unit of electrical current. So when we talk about a piece of equipment being amp seeking, that means it's going to adjust other variables in order to get a target amount of amps coming to the machine. So, how does a WF Meyers Quarry machine or any other piece of equipment that is amp seeking maintain that amp set point? It sounds complicated, but the concept's pretty straightforward. A proportional integral derivative controller, or PID for short, is what gets our amperage to the target set point. The easiest way to think about this is like the cruise control in your truck. If you set the cruise control to travel 70 miles an hour, your truck will automatically make adjustments if you're going uphill or downhill so that you stay at 70 miles an hour. Similarly, a PID on a piece of equipment is going to change other variables to ensure that the equipment is hitting that amperage set point it's looking for. So what gets tweaked in a WF Meyers Quarry saw in order to keep the amperage at the set point? The answer there is travel speed. So the machine can't control the stone that it's cutting, but it can control how fast the saw is moving down the tracks. So that's the variable that the PID adjusts in order to keep the amps right at the set point. Since I'm not an engineer, and I got a C in the only physics class I've ever taken, I've had some people smarter than me use really small words in order to explain this concept to me. Think of the amps in a PID at the PID set point as a pie. So if we've got our amperage set to 70, we've got 70 amps total devoted in the pie. Now, if we fire up the main motor, that takes a big slice out of the pie. If we then add a bar and a quarry belt on, that takes another little slice of the pie because it takes energy to move the weight of that belt on with the motor. We add water into the mix to lubricate and clear out the cut. That also takes a slice of the pie because it takes more power to move that water through the cut. So all of these factors take a little slice out of the pie, of that 70 amp pie, and what's left is what's able to devote to the travel speed on the saw. So the amps that are left over to devote to travel, I like to call those our free amps because they're free to go do what we want the machine to do. So it's pretty common to have a customer with multiple saws reach out to us and say, hey, I've got two saws, they're on the same ledge, they're cutting the same stone, they're cutting this with the same belt, and we're seeing different results in terms of inches per minute that the saws are traveling. And oftentimes what happens in that case is, while the customer hasn't intentionally changed any variables, something is stealing a piece of that 70 amp pie or whatever the set point is, and not allowing the saw to travel. So if one saw has, I'm just going to pick a number and say 10 amps to devote, 10 free amps to devote to traveling the saw down the track, and another only has 5 amps to devote to traveling the saw down the track, then it's pretty clear that the saw with more amps available to devote to the travel speed is going to end up moving faster. So what we would encourage customers to do is take a look at their motors idling and account for things like a new belt versus a belt that's nearing the end of its life, because that belt's going to be smaller, lighter, takes slightly less amperage to run. Could be a bearing going out that's creating some friction and drawing some additional amperage. So it's not always a belt problem or a stone problem when a situation like this arises. So why not just ramp up the amps in your set point as high as you can go, and then you've got as many free amps available as possible to devote to traveling the saw down the track and cut just as fast as you can. Well, it's a balancing act. If you're running at higher amperage, you're more prone to damaging belts, you're more prone to damaging the saw, damaging consumables on it, and you're also maybe prematurely wearing out your tooling. So it's a sweet spot between production and operational cost in additional maintenance and additional tooling. So every company kind of has to find their own balancing point where you've optimized for production and also optimized for tool life and minimizing your operational costs. So it is a balancing act, and there's no real crystal clear answer I can give you on what's going to work best for you. So while this video has focused on the WF Meyers Quarry saw and how it handles amperage with a PID, this really applies to a lot of equipment in the stone industry. I know in the mill, Standish block saws, Benetti block saws, Diamond Stone Technology block saws, Park Industries block saws, I believe most, if not all of those, have that same amp following mechanism. I think a lot of your circular blades do. So diamond wires may as well. It's pretty common. So the way it works for the WF Meyers Quarry saw, you can draw a lot of parallels to how that's going to work with really any piece of equipment, whether you're cutting stone or no matter what you're doing. If it's amp following and has a PID loop in it, this is how it's going to work. So there's your overview on how amp following equipment like the WF Meyers Quarry saw works. If you would like to be an insider, go ahead and subscribe to this channel and head on over to stoneindustryinsider.com, where you can sign up for mailing lists and get information on topics including WF Meyers and our quarry saws. If you got thoughts, please leave them in the comments. Would love to hear what you think. And thank you for watching. I'll catch you next time.